Hello, I'm going to now go over the fourth lab for our physics class. So the introduction, the purpose is to observe and compare predicted motion on glow script to observe motion on tracker for a mass attached to a spring. And we're going to plot the change in position of predicted motion onto the observed motion, and we're going to plot the energies from the predicted models. And the expected results are the change in total energy should be zero, and the predicted values and the observed should be fairly similar. So some of the applied ideas are the first applied idea is Newton's second law, where you get the net force equation, which basically means the change in momentum over change in time. And from there, we get the velocity update equation as well as the position update equation that we used all through Unit 1, Unit 2 of the physics class. The second applied idea that's more important is the energy principle, where the change in energy of a system is actually equal to the work done plus the surrounding heat that it's exchanged between the system and the surrounding. And specifically for this experiment, we're going to be using this equation right here, where the total energy change in the energy in the system is the change in kinetic energy plus the change in gravitational potential energy plus change in spring potential energy. Another portion of this idea is that energy is neither created nor destroyed. And in this project, the system will be the block, earth, and spring. The surroundings will be nothing. And since the surroundings is nothing, there should be zero work on the system. Some equations we're going to be using is the first equation is the equation we spoke about before. We're also going to use kinetic energy is 1/2 mv squared. And the potential gravity is mgh. Potential spring is 1/2 ks squared. So here is the video of the tracker. As you can see, it oscillates up and down like this. And note the calibration stick is set to 0.7 meters. So the initial conditions for this is the ball's mass was set to 0.402, and the position, this vector was set through the tracker app. And then from the pre-lecture videos, we have the K value at 6.83 and the relaxed length as 0.123. And this is the actual glow strip code. So if you look on the left, you have the L, which is like the springs, like it's the spring compressing and the spring pulling. And we found that, and then we found the kind of like the original system's kinetic energy and the potential energies to find the full total energy. And then this on the right is inside the while loop, where we found the force of the gravity and the force on the spring to find the total force. And then we found, using Newton's second law, the velocity and position of that ball. And then we updated the kinetic energy as well as the potential gravity and spring energies so that we can find a change in them for the next round inside of the while loop. So as you can see inside of these graphs, this first graph is like the predicted one, where we could see there is the delta, the change in potential gravity and the change in potential spring forces, and we can see the change in kinetic energy. And then, of course, the change in energy, the total energy should be zero because there's zero work done on the system. And then, as you can see on the right, there is the actual graphs comparing the experiment to the model that we created through Tracker. And as you can see, the model slows a little bit due to the drag, but the experiment doesn't because it's a perfect scenario. So what does it mean? Is the is the energy principle satisfied? In this case, we can see that the energy principle is actually satisfied. As shown before, in the energy principle, no energy is actually lost. But in this case, we can see that and then it should add up to zero, since there's zero work done, since there is nothing in the surroundings. And we can see the delta E is actually zero. Why? Because the change in the potential gravity and the change in the potential spring energies, they cancel out. As you see, the waves are canceling out to zero. And then the change in kinetic energy is constantly oscillating. So it also kind of balances out to zero. So in the end, it yields a zero total energy. Thank you.